Hi, how are you doing on YouTube? Welcome to Python Coding and Chess World, a project I started over a year ago when I learned how to code up a board similar to one of the chess websites, chess.com, I believe, with the objective of building an algorithm that will enable an auto-random play chess engine, which will be part of a further developments down the road to create a chess AI. Earlier on, I had coded up some work on the pawns, and then that was stopped, and recently I've continued with the work, which has now reached a point where all of the pawns, all of the knights, rooks, bishops, queens will move randomly around the board, but correctly. The king has not been put into that function as of yet. This is a work in development, and we'll go through running the algorithm and showing the moves on the board, and then I'll go to my GitHub and run through the functions very quickly to give you some gleaning idea of what's happening. So we'll start off with a look at the board. This board, the pieces need to be acquired from a site. The chess piece graphics were obtained by searching for the images, and the images were then placed on paint and identified, cut out, and then were moved over to a directory on PyCharm. So we might as well go there and take a look at the setup. So this is the board, and these are the images I have. You need to deposit the images in a directory. So all my images are in a directory. They have to be given a name appropriately, and then they'll be placed on the board with a function, which we'll come to later. So you have to do that. And I have copy paste. There is multiple queens. There's up to a possibility of 5 queens that can be obtained during running the algorithm. So I'll run the algorithm off twice, run slowly, and then we'll run it fast right to the end when it'll stop when there's no more pieces capable of moving. So we'll just run this at 420 moves. When the pawns get to the 8th rank, they will be promoted to queens, and they will go on and capture all the pieces eventually until there is no more pieces left on the board. But we'll just play it slow for you to see it in action. So that's that. Now we'll speed it up and run it out to the end. Let's just change the time. It's a little faster. And now we can run that out till there's no more pieces left on the board. And it'll capture, and it'll make queens, and they'll do their thing. It'll capture the king because it's not set up to checkmate or anything like that yet. And I'm just printing out my data on the side for verification of the algorithm working. So that is the algorithm running, and the next step is to just go and look at my GitHub. The code is up on my GitHub, and I'll just run through this very, very quickly, give you some idea of what it is. The graphics are using a tkinter package. All of the movement function come from tkinter movement functions, and I'll just go through the functions. There are certain stuff that could be in the init which are not there. So the pieces are defined. The board is defined with spaces for placing the pieces on the board. You have to learn how to use tkinter graphics for that. I employ 2 arrays to hold the information, which are the same. So one holds an image of the piece in letter form and a space, and the other one holds the coordinates for placing the piece and moving them around the board, because we'll need both. The board is built with displacement values. That's building the board. Putting the pieces on the board. This is the code you use for putting the pieces on the board. You have to identify the piece that you have in that directory to get it to be put onto the board. So that deals with the pieces. And then we'll just go through the pawns, all of the piece functions. There will be indexes which show where the pieces can move to. So in the case of the pawn, it can move up or it can capture either side. So after it's moved, it's made its first move, which is special. It has a 3 horizontal vector, and we'll move down to something a bit more complicated, like the knight. The knight has 8 potential moves, and this is displacement vector positions for all of those 8 moves. They are added to the vector of the current selected piece, and the combined output of those which are off the board get removed in various aspects of removal, which get more complicated as we go down. Some of this could be put in the init. As I said, this is a developmental phase of the algorithm. The bishop has 4 different directions it can go in: top, bottom, left, right. There are 4 vectors as such, and those that are off the board are summarily removed from the algorithm. Then one of these vectors is chosen for the vector space that you're going to be choosing your move from, and then from there that move will be chosen and it will be moved on the board. And that's pretty much the same all the way down through the rest of this. I've tried to label it appropriately with some sensibilities to understand. The rook is similar to the bishop, and the queen just combines both of those functions, and we get down to her ladyship, which is down here somewhere. Okay, so the queen has got obviously 8 directions it can move in, and once again those moves which are off the board are removed, and one of those 8 vectors are selected, and from within that vector space a particular move is selected. Move on to the next function. That's just black queen. Where are we? Pawn promotions. Okay, so pawns, when they each reach the 8th rank, are promoted. They're removed from the board by the same method that you move pieces on the board, only they are just summarily moved a large number off the board. And the queen is then replaced, the piece is then replaced with one of your image queens onto the board in that position. So that's doing the promotion there, and the same goes for black. And there is another function that removes pieces from the board when they're captured. Everything moves via the piece vector. When you run the algorithm, which we'll get down to, it calls the piece vector, which then goes and asks which piece you want to select to look at to see if it's got a move, and then move it if it has one. Otherwise it will loop back into here and select another piece. That's where you'll get a new piece when it has no moves available to it legally. Labels on the board are connected to moving the piece with the t-Kinter graphics algorithm. The way the t-Kinter graphics coding works, it's just given one name, and that's the way that functions. And so all of the pieces that are going to be moved are identified by this little algorithm here to identify them as what the agent is actually carrying. There are 2 types of these, one for moving the pieces around the board and another one for moving the pieces off of the board altogether, which happens to be here. So there'll be 2 lots of these labeling graphics. So that goes through that. When you get to the point where you captured a piece, the piece will be function will be called from within the run function. It will come in here, and once again it will remove the piece off the board, and will change the graphics on the graphic printout, which comes along with it. And this is the move function, which will start off by calling in its appropriate data, and somewhere in here we'll find, where are you? There, we'll find here where it's calling that vector, and then it'll get the move from there, and appropriately down for the black. this little algorithm here moves your piece on the graphic, replaces the position on the graphic with a space, and updates the graphic, which you'll see when it's run, when the code was run. We come back over here and we can see this is the printout. We'll just put it on a single move or something like that. Where are we? Let's just run it down. I'll say 4 moves, and we'll see the graphic come out. So now you can see the graphic where it's replaced the pieces and moved them appropriately. And that's it. It's open source. You are free to do with the code and distribute it how and wherever you want to.